Hello everyone, in this video we're going to talk about how we can perform some rotations. All right, now I'm doing this specifically for my pre-algebra course here on my channel, but we will talk about rotations in geometry as well. So I have a video that I've made for my geometry course about rotations already on my channel, but I will link it in the description of this video. Okay, so let's get into this one. A rotation is just a turn. It's a transformation in which a figure is rotated about a point called the center of rotation. Most of the time that center of rotation is going to be the origin when we're looking at doing rotations on a coordinate plane, which we will look at the end of this video. The number of degrees a figure rotates is called the angle of rotation, and the three most popular angles of rotation that you're going to see are 90 degrees, 180 degrees, and 270 degrees. Depending on the textbook or the test, these rotations might be clockwise or they might be counterclockwise. So you just have to pay attention to what that's saying. And it's referring to a clock, an analog clock, which I know we don't see that often anymore, but there is one right behind me. So if we look this way, I know it's not working, but going like this, following my finger, right, that would be clockwise because the hands on a clock are going to go that direction. Counterclockwise would be going the other direction like this. Okay, so that's what we mean by clockwise and counterclockwise. So if I look at the thumbs up here on the screen, we have our original thumbs up here, and then we're doing just a little bit of a rotation each time. So to go from the original to the 90 degree, that's what a 90 degree rotation would look like. And then we're going from original to 180. Okay, we're turning it almost, half of all the way around, right? Because 360 would get us back to the same position. So 180 would be kind of halfway. And then the last one here would be from the original to a 270. Notice how we're almost back to the thumbs up position because it's a quarter turn or 90 degree turn away from being back to 360, which would be back in the original position. Okay, so now let's look at what this would look like on a coordinate plane with an X and a Y axis. So let's say we're starting here in quadrant 1 with our original shape, thumbs up, and we're going to reference these rotations as clockwise. We'll talk about counterclockwise in just a minute, but as far as clockwise, so a 90 degree clockwise rotation would take us down here into quadrant 4. And if we wanted to do a 180, right, we would go all the way here actually to quadrant 3. And then if we wanted to do a 270, we would end up here in quadrant 2. Okay, so we can see this angle of rotation or the point of rotation here in the middle, which would be the origin, and notice how we are rotating here clockwise. Okay, all right, so now let's talk about how this would look in a coordinate plane and in the reference of counterclockwise. So when a point x comma y is rotated counterclockwise about the origin, the following are true. So we have some coordinate rules that could help us really to rotate shapes that we know the vertices of without even having to graph them. So if we have a 90 degree counterclockwise rotation, notice what happens to our coordinate. First of all, we're going to switch x and y, and then the y coordinate is going to become opposite, right? So you can kind of think about that in one of two ways. One, you could think, okay, my original coordinate, let's go ahead and make y opposite, and then let's switch those two numbers, right? The other way is you can go ahead and switch them, but then in that case, if you go ahead and switch them first, you have to be careful to remember to make sure your original y coordinate is the one you're making opposite, right? So I usually prefer to make the y coordinate opposite first and then switch the coordinates for a 90 degree counterclockwise rotation. For 180, it's a little bit easier. We don't have to switch the coordinates, we just make both opposite. So x, y just becomes the opposite of x and the opposite of y. 270 is similar to a 90. We are switching the coordinates again, but this time we're going to make the original x coordinate opposite, right? So this is what the coordinate rules would look like for counterclockwise. Now, clockwise, we can write over here, clockwise, essentially, right, a 90 degree counterclockwise rotation would be the same as a 270 clockwise rotation, right? Likewise, a 270 counterclockwise would be the same as a 90 clockwise. Okay, so you can use these coordinate rules for counterclockwise that we're remembering here and just kind of think about if it's a 90 counterclockwise, but it's asking me to write that in clockwise, then it would be 270 and you can go back and forth between the two. The good thing about 180 is 180 clockwise is the same as 180 counterclockwise, so all good there, okay? So as far as our examples are concerned, let's just take a look at a set of coordinates here and let's perform one of each of these rotations to see how the coordinates would actually change. So for number 1, we have a quadrilateral ABCD, 4 coordinates, 4 vertices, and we're going to do a 90-degree counterclockwise rotation. Okay, so counterclockwise, notice up here, we're going to make y opposite, and then we're going to switch x and y. So -4, -4. So I'm going to think in my head, okay, this is going to be -4, +4, right? I made the y coordinate opposite, and now I'm going to switch those. So it's actually going to end up being 4, -4. That would be our final coordinate there. Okay, so I'm going to do it that way. The one I write in the middle, I won't write in parentheses. That's just us making the y coordinate opposite. And then the one that I write in parentheses, that's the actual final coordinate with us switching x and y as well. Okay, hopefully that makes sense. For B, we're going to write it as -4, -2, and then we're going to switch those. So -2, -4 would be our new coordinate after the 90-degree counterclockwise rotation. Now, C is a little bit tricky because the opposite of 0 is still 0, right? So nothing changes there. And then we just switch these coordinates, so it's 0, -1. For D, we're going to write -2, 3, and then we switch those so it becomes 3, -2. That would be our final coordinate. Okay, so that's a 90-degree counterclockwise rotation. All right. Okay, 180, we don't have to do the step in the middle, right? Because it's kind of just one step. We just make both opposite. So for A, we would go from -3, 2 to 3, -2. B, we would go from 6, 1 to -6, -1. And for C, we'd go from -1, -5 to 1, 5, right? So 180, a little bit easier. No switching of the coordinates, just making both opposite. All right, and our last one, 270. So now this time we're going to make x opposite, and then we'll switch, right? So 5, 3, we're going to do -5, 3. And then we switch those, and it becomes 3, -5 for our final coordinate after the 270 counterclockwise rotation. All right, B is 4, -1. So let's write this as -4, -1. And then we're going to switch those to become -1, -4. And then our last one, C, this will be -1, -1. And then we switch those, which stays -1, -1. Okay? All right. So those are our examples there for each of the rotations that we might see, a 90, a 180, and a 270. And we did those counterclockwise, right? Just kind of depends on the textbook or your course, whether they prefer counterclockwise or clockwise. So really that's the main thing to pay attention to. And as a reminder, I have a video for this for geometry in the description below if you want to take a deep dive into a little bit more about what this is going to look like when you get to geometry. All right, but for now, that's how you can perform some rotations.